Required to find the function y whose differential equation is given. Rearrange terms of the equation and we have that dy over 3 equals dx over the sum of the square of x and 4. Integrate the equation. It implies that integral dy over 3 equals the integral of dx over the sum of the square x and 4. We call it equation y. From the right-hand side of the equation, let us integrate the expression with respect with x.
Thus, by trigonometric identity, the sum of the product of 4 and the square of tan u and 4 equals the product of 4 and the secant square u. For the square of x equals the product of 4 and the square of tan u. Find the square root of the equation. We have that x equals the product of 2 and tan u. Thus, u equals tan inverse of half of x. We call it equation 1. Let us find the derivative of the equation. Dx equals 2 times secant square u du. Substitute this in the given integral expression and integrate them. We have the sum of half of u and constant term, k. But u equals tan inverse of half of x. Then, substitute it into the result obtained, and we have that the integration of dx over the sum of the square of x and 4 equals the sum of the product of half and tan inverse of half of x and k, the constant term. Substitute it into equation y and we have the result shown on the screen. Integrate the left-hand side of the equation. This implies that y over 3 equals the sum of the product of half and the tan inverse of half of x and k. Multiply the equation by 3 to clear fraction and we have that y equals the sum of the product of 3 over 2 and the tan inverse of half of x and 3 times k, where 3 times k equals c, the constant term of the integration. Thus, y equals the sum of the product of 3 over 2 and the tan inverse of half of x and c. And at x equals 2, y equals 0. Substitute it in the integrated function and simplify. We have that c equals negative 3 times pi all divided by 8. Substitute in the integrated equation for c to find the function y, as shown on the screen. Therefore, y equals the sum of the product of 3 over 2 and the tan inverse of half of x and negative 3 times pi over 8 is the required function, y.